Hi, hello, namaste. Welcome to my channel Chemistry Wala Alam. Right. So in the last video, I had explained about the introduction of the organic chemistry, okay, and how to write the structure. So in this video, I am going to explain about the more important topic in the organic chemistry as well as in the chemical bonding also. That is the hybridization. Hybridization. Why this topic has been introduced? What is the reason behind this for introducing the hybridization concept? So in the last video I had discussed that atomic number of the carbon is 6, its electronic configuration is 1s2, 2s2, 2p2. So here K cell, L cell is the valency cell, L cell containing the 4 valency electrons. So these 4 valence electrons means it belongs to 4a or 14th group. Its valency is 4. Valency can be defined as the combining capacity of an element. Okay, so valency is 4. So by seeing this, electronic configuration can be take 2s2 means 2 electrons and p orbital means 2 electrons in the p subshell. So it is expected to, that means it is having the 2 valence electrons. So if it is having the 2 valence electrons, it must be forms the 2 bonds. 2 bonds only must be formed, but practically it is forming the 4 bonds. Then what is the reason behind this? So here this is called ground state electronic configuration. So here what's happening is, here one of the, here 2s orbital, this is a 2s 2p, and one electron will be jumps to here s orbital to p orbital. One excitation electron can be jumps to s orbital to p orbital. Then what happens automatically in the excited state electronic configuration? Then what happens here, 2s orbital is having 1 electron and 2p already it has the 2 valence electrons, that means 2 unpaired electrons, and third electron also will be goes here. So now finally it has the 4 unpaired electrons. So that's what here according to Lewis, which are having the 8 valence electrons, those are more stable. So that's what here it need to gain the 4 electrons or lose the 4 electrons. So gaining a 4 electron is not possible, and losing of 4 electrons also not possible. That's why here what's happening, sharing of electrons. Suppose here hydrogen atom is available, that is containing the 1 electron, okay na? So that 1 electron can be bonds forms like this. Suppose here one more hydrogen, here one more hydrogen. So here, what's happening here, hydrogen also need 1 electron, carbon or need the 4 electrons. So these 4 electrons can be bonded with 4 hydrogens or whatever available elements, suppose oxygen or sulfur or any other carbon. So it can be forms of 4 bonds, okay na? So here if you observe clearly, so 2s orbital is somewhat less energy than the 2p, okay na? That's what in the representation will be right somewhat downside the 2s orbital, okay na? The 2s orbital will be right somewhat the downside. So it represents, when compared with the p orbital, 2s is low energy. These energy levels can be discussed in the atomic structure, we can already discussed. So here which is having the low n plus l value, that is indicating that low energy, which is having the high n plus l value, that is the high energy. That's what here 2s is low energy and 2p is somewhat the higher energy when compared. And 2s orbital is spherical, p orbitals are dumbbell along the x-axis, along the y-axis, along the z-axis, dumbbell shape. So here if you observe that change in the energy, okay, next change in the shape and sizes, then it is expected to form the 4 different bond lengths. That means when carbon is forming the 4 bonds. So those 4 bonds will be 3 bonds. So 3 bonds should be the same length, and 4th bond should be somewhat the change in the length or energy. But practically 4 bonds are having the equivalent length, that means same length, that is 109 picometers. Okay, now this is the bond length and bond angle. So bond angle in the methane molecule is observed that 109 degrees 28 minutes, 109 degrees 28, or you can be right 105.5 degrees, 105.5 degrees, because 60 seconds equals to 1 degree. 109 degrees 28 seconds, okay, or 28 minutes. So here how it is possible? If electron present in the s orbital and 3 electrons are present in the 3 p orbitals, then it is expected to be the bond length and shapes of the molecule should be different. Bond angles also should be different, but experimentally, so the all bond lengths are same in length, and bond angle, the bond angle is nothing but the angle between the 2 bonds. It is called bond angle. This bond angle is also same among the in between any any adjacent bonds. So this concept was explained by the concept hybridization. So this hybridization concept was given by Linus Pauling. So to explain the mainly shapes and bond angles, to explain the shapes and bond angles of the compounds, Linus Pauling had given the concept of hybridization. So what is the hybridization, and what are the types of the hybridization? Then how can we find the hybridization? How can we calculate for a given compound? How can we say that the which hybridization is present in the particular compound? Okay, let us go and discuss. So first one is definition of the hybridization. So here hybridization is the regarding mainly orbitals. Okay, now so definition can be said that so the intermixing of 2 or more atomic orbitals, which have slight energy differences, redistribute so as redistribute their energy and shape, forming a new set of orbitals, called hybrid orbitals, new set of orbitals which are having equivalent shape and energy. It is looking like somewhat lengthy. It very simple and also more important. In the chemical bonding we can be discussed. In the chemical bonding, particularly hybridization in the beryllium chloride, boron trifluoride, again a water molecule, ammonia molecule, hydrogen molecule, chlorine molecule will be discussed. But in the organic chemistry, only carbon and its compounds will be discussed, like ethane, methane, ethene, Okay, next one is ethine, like these molecules. So first of all, definition of the hybridization, you can see intermixing of two or more atomic orbitals. What are these atomic orbitals here? S, P, D, F, atomic orbitals. Intermixing of these orbitals which have the slight energy differences. So the energy difference, just now we have seen that 2s, 2p, slight energy difference. 2s, 4s or 2s, 3s will not be overlap. Okay, na? Which have the slight energy differences. So by that what happen? So as redistribute their energy, and shape. So what we are forming a new set of orbitals. Those new set of orbitals are called hybrid orbitals, and these hybrid orbitals are having the same energy and same shape, same or equivalent shape and equivalent energy. So finally what can be say that atomic orbitals are redistributed and can be used that hybrid orbitals. So here atomic orbitals are different shape and different slight energy differences, but here these are having the same shape and same energy, clear? Same shape and same energy. Okay, right. So atomic orbitals are redistributing among themselves and forming a set of orbitals. New set of orbitals are called hybrid orbitals, which are having the same energy and same shape. So this phenomena is called hybridization. So the intermixing of two or more atomic orbitals which are having the slight energy differences redistribute their energies and forming a new set of orbitals which are having the equivalent shape and energy is called hybridization. The phenomena is called hybridization. The formed set of orbitals are called hybrid orbitals. So here, based on involving the atomic orbitals, how many number of atomic orbitals are involving, based on that, here hybridization is mainly in the organic chemistry. Will be see that sp3, sp2, sp, three kinds of the hybridizations you can be see. Right, one by one we can be discuss. First of all, sp, sp2, sp3. Okay na? So here intermixing of one s orbital, one p orbital, that gives rise to sp orbital. Intermixing of one s orbital, two p orbitals, that can give the sp2 hybridization. Here 2 plus 1, 3. Next one is one s orbital, 3 p orbitals, that can give that sp3 hybridization orbital. So totally 4. Okay, right. So here what are the rules for writing that hybridization? Okay, now what are the main rules for writing the hybridization? You can see. So first one is orbitals of the same atom. Orbitals of the same atom only involving the hybridization. Suppose it can be take that carbon, atomic number is 6, electronic configuration 1s2, 2s2, 2p2. So in the excited state you can be write, so 2s1, 1s1, 2s1, 2p3. So here same atom, orbitals of the same atom. Suppose 2s orbital and px, py, pz, 2px, 2py, 2pz. These carbon orbitals cannot be intermixed with any other atom. Orbitals of the same atom only involved in the hybridization. And second point is these atomic orbitals are having the slight energy differences. So if the difference is the more, then it cannot be undergoes the hybridization. Suppose 1s and 2p will not undergoes the hybridization, okay na, or 2s 3s or 2s 3d will not be undergoes the hybridization. So the second condition is here, the atomic orbitals whatever they are undergoing, they should have the slight energy differences, okay na. And here number of atomic orbitals is equal to number of hybrid orbitals. That's why I have written here 1s 1p. So it is giving the only 2 sp orbitals, then 1s orbital, 2p orbitals. 2p is nothing but this 2p orbitals, okay na, like to px and py. Here 3p orbitals, px, py, pz. So 1s orbital, 2p orbitals giving the 3 sp2, 1s orbital, 3p orbitals giving the 4 sp3. Okay, because here number of atomic orbitals equals to number of hybrid orbitals, like Lavoisier given law of conservation of mass, number of atoms on the left side is equals to number of atoms on the right side. Here also how many number of atomic orbitals are involving, same number of the hybrid orbitals. So next point is, these hybrid orbitals are arranged in a symmetrical distribution. So symmetrically they can be arranged. So here the symmetrical distribution also, the hybrid orbitals around the central atom should be move as long as possible, because to minimize the repulsions, when the repulsions are minimized will get the stability, okay na. So to minimize the repulsions, okay na, they can be moved in the that means around the central atom they can be in a symmetrical distribution matter, they can be arranged. Next one here, electrons in the hybrid orbitals. Electrons in the hybrid orbitals filling order can be follows the two rules. So that is the Pauli's exclusion principle, okay, and second one is the Hund's rule. Two rules it can be follows here. Which one? Pauli's exclusion principle and Hund's rule. According to Pauli's exclusion principle, the electron will be filled based on their increasing energy levels. And then here Hund's rule. Hund's rule is nothing but pairing of electrons will be takes place after filling of all available degenerate orbitals. Next here, any hybrid orbitals are maximum capacity to fill only 2 electrons. The 2 electrons also in the opposite direction. Again, one is the clockwise, second one is the anti-clockwise direction. Okay now, and here these hybrid orbitals are mainly, so they can form only sigma bonds. They can form only sigma bonds. They won't form that any pi bond. So they will form only sigma bond. Okay na. Right, here these hybrid orbitals are mainly involving in the to predict the shape and also bond angles. Regarding bond angle, one more point it can be discussed. So the bond angle in between the any two hybrid orbitals, adjacent hybrid orbitals will be same among the all hybrid orbitals. So the bond angle distance, the bond angle between the any two adjacent hybrid orbitals will be same. So based on this concept, here we can see that which one here, carbon is having the 4 valency electrons. So those 4 valency electrons are, before they are forming the bonds, 2px1, 2py1, 2pz1. These all are the p orbitals. This is the s orbital. So here what's happening? Here 1 electron, 2s, 2px, 2py, 2pz. So if these all can be undergoes hybridization, these all can be undergoes the hybridization, then what happens? 1 s orbital plus 3 p orbitals. So it can give the how many totally? 4. Number of atomic orbitals equals to number of hybrid orbitals. Okay now, 1 s orbital, 3 p orbitals. So that is giving the 4 sp3, because only 1 s, there how many p are 3. Next one is, Here suppose only one s orbital and two p orbitals can be undergoes. One s orbital, two p orbitals can be undergoes. Total how many? 3. 1s, 2p. So that is called sp2 hybridization. And if only one s orbital, one p orbital can be undergoes. One s orbital, one p orbital can be undergoes. 1 plus 1, 2 s and p, sp. S and p, sp. Okay, now this is the based on number of atomic orbitals involving in the hybridization, different types. Here mainly in the organic chemistry will be discussed only 3, sp, sp2, sp3. Okay, in the chemical bonding we will be discussed about the sp3d, sp3d2, sp3d3. Okay, now dsp2, d2, sp3, like all can be discussed. But in the organic chemistry only will be discussed about the 3. Okay, so one side you can see that. Here rules for writing the hybridization. So first one is atomic orbitals of the same atom. That means only carbon atomic orbitals only involved, and different atoms atomic orbitals will not be involved. These atomic orbitals are should have that slight energy differences which are undergoing the hybridization. Those must have the slight different energies, and this here number of atomic orbitals involving in the hybridization, that is equals to number of hybrid orbitals are forming. So atomic orbitals equals to hybrid orbitals. These hybrid orbitals are formed due to hybridization. Those can be distributed around the central atom in a symmetrical distribution to minimize the repulsions, so they can be moved as far as possible. Next one here, electrons fill in the hybrid orbitals or filling electrons can be follows the two rules. One is the Pauli's exclusion principle, second one is the Hund's rule. Next one is hybrid orbitals. Any hybrid orbitals will have that only 2 electrons. So 2 electrons with opposite direction. Next one is hybrid orbitals forms only sigma bonds. Okay, now these sigma bonds can be predict the shape of the molecules, bond angles also. And here bond angle, so the bond angle in between the any two hybrid orbitals, adjacent hybrid orbitals will be same. So based on this concept, so here carbon is having the which one? Carbon is having the same bond length, that is a 109 picometers. The bond length, 4 bonds are having the same length. Okay, na, and bond angle is 109 degrees 28 minutes. 109 degrees 28 minutes. In between any two bond angle, that means bonds you can be take that angle. The bond angle is 109 degrees 28 minutes. This is the reason, because before forming the bonds, these 4 electrons are intermixing. Okay, now partial, that means intermixing of atomic orbitals, saying that, and result in the formation of 4 set of orbitals, hybrid orbitals, which are having the equal energy, equal shape, same energy, same shape. That's why those are bond lengths are same, bond angles also same, even though the electrons are in the s and p orbitals. The reason is behind here. Here this is a hypothetical phenomena. So Linus Pauling has said this, which one? Hybridization, intermixing of atomic orbitals. Okay, right, one by one can be discussed. First one can be discussed, that sp3 hybridization. Okay, first one is sp3 hybridization. So here, what is sp3? Okay, now how it can be formed, then how can we calculate this hybridization? So sp3 hybridization. So here the mainly 1 s orbital plus 3 p orbitals result in the formation of 4 sp3 hybridized orbitals. Intermixing of 1 s orbital, 3 p orbitals result in the formation of 4 sp3 hybridized orbitals. Right, here 1 s orbitals are spherical. Next one, p orbitals are is the suppose px, py, and then pz, x axis, y axis, z axis. Totally 4, 1 s orbital, 3 p orbitals. So finally how many should form? 4 sp3. So here 1 s orbital, 1 p orbital can be given like this. This is the p part, this is the s part. Again like this, how many? 4, 2, 3, 4. Carbon atom is exactly in the center. Okay na, 4 hybridized orbitals. So S is having the 1 electron, and also px, py, pz, so 3 electrons. So each one will be occupies that 1 electron, because here energy is the same, shape also same, the 4 electrons also equally distributed. 4 electrons also equally distributed. Now this is the carbon atom. Okay, and this carbon atom can be overlap with hydrogens. So here this is 1, 2, 3, 4. So each 1 electron is present in this, like a regular tetrahedron structure. sp3 is a tetrahedron structure. That's what here. Again here, this can be overlap with hydrogen, this can be overlap with another hydrogen, this can be overlap with another hydrogen, this also can be overlap with hydrogens. Okay, so by that what happen, here pair of electrons, pair will be formed. Here also pair of electron with opposite pair of electrons. Here also pair of electrons will be formed. Again, this is indicating that hydrogen is having the 1 electron, its electronic configuration is 1s1, that means 1 electron is present in the s orbital. So that's what we have drawn with like a circle. Okay na, and this is the sp3 hybridized orbital. So here 4 sigma bonds like this can be represented. Central atom, this is the carbon. Okay na, 4 bonds are sigma bonds, because single bonds, remember single bonds always sigma bonds. And also you know that here all are hybridized orbital, 4 hybridized orbital, each one can form that 1 sigma bond. Like that 4 hybridized orbitals, 4 sp3 hybridized orbital will be formed that 4 sigma bonds. Okay, right. So here the bonds are sigma sp3s, because sp3 bond is sigma bond. Then how it formed? Overlapping of sp3 orbital and then s orbital. Like that, this is also same. That means 4 sigma sp3 s orbitals are present. Okay, right. This is the sp3 hybridization. In there some important information. Here percentage of the s character is 25%, and p percentage that equals to 75%. How can we calculate this percentage? Number of orbitals by total number of orbitals into 100. s orbitals 1, total 4 into 100. Here total p orbitals are 3, total number of orbitals are 4 into 100. Then we will get the percentage of the s and p character, s and p percentage. Next one, here bond angles. Generally, if the sp3 hybridization is without any lone pairs, that means regular tetrahedron, so the bond angle is 109 degrees 28 minutes. 109 degrees 28 minutes. In this methane molecule, the bond length is 109 picometers. In the methane molecule, carbon hydrogen bond length is 109 picometers. Okay, now 1 picometer equals to 10 to the power of minus 12 meters. Okay, now you can write like this, into 10 to the power of minus 12 meters. Okay, now because these atoms are very small, that's why here those can be represented in the nanometer, picometer or angstrom unit. Okay, right. So this is the somewhat information about the sp3 hybridization. So in the sp3 hybridization, regular tetrahedron, tetrahedral structure. Bond angle is 109 degrees 28 minutes. Okay na, 1 s orbital intermixed with the 3 p orbitals, sp3 hybridization. This is a very simple one. Okay, next one is sp2 hybridization. sp2 hybridization. here sp2, one s orbital, two p orbitals, total how many? 3. Intermixing of one s orbital and then two p orbitals result in the formation of 3 hybrid sp2 orbitals, sp2 hybridized orbitals. So here we'll be take that one s orbital and two p orbitals, px, py. Then what about one more? One more is that will not involve in the hybridization. Okay na? So that's what here what can be forms. 3 will be forms. Okay, 1, 2, 3 hybridized orbitals, and one will not involve in the hybridization. One will not involve in the hybridization. These are the sp2, sp2, sp2. This is the which one? 1p orbitals is the unhybridized orbital. Unhybridized orbital is nothing but which not involves in the hybridization. That means here carbon 1s2, 2s1, 2p, 2p3. That means one s orbital and p orbitals are how many involving here? Only 2. The third one is not involved in the hybridization. That is called unhybridized orbital. Unhybridized orbitals. Okay now, these unhybridized orbitals can be forms of pi bonds because here lateral or sidewise overlapping will be takes place. Sidewise overlapping. So sidewise overlapping is formation of the sigma pi bonds. Okay now, that's what here. This is the one sp2. Okay now, like that two sp2 hybrid orbitals can be see that. So in the ethene molecule, eth is nothing but 2 carbon atoms. So like that 2 will be takes place. Will be take that 2 carbon atoms. Okay now, one is the unhybridized orbital, totally 4, plus one more hybridized orbital s carbon, and this is the unhybridized. Okay na, unhybridized I will be draw with thick. This is the unhybridized orbital. Okay na, this is the hybridized. So by that what happen here between the two? What happen here? End on end overlapping. Okay na, end on end overlapping, that is called result in the formation of sigma bond. So I will be draw here. This is the 1, 2, 3. So this one is over partial merging. So like this it can be overlap. Okay na, end on end is sigma bond can be formed. End on end is sigma bond. Then here one electron, here one electron, here one, here one. Here what happen? 2 electrons. Then sidewise will be sidewise orbital. Sidewise orbital, what happen here? Sidewise overlapping will be takes place. Unhybridized orbital will be. So this unhybridized orbitals is result in the formation of 1 pi bond. Okay now, so this one can be represented. This is one carbon, this is one carbon. So you can be write this like this. First one sigma bond and then one pi bond. One is sigma bond, second one is the pi bond. And here this can be overlap with s orbital. This also can be overlap with s orbital. Yes, yes, like this. Hydrogen, 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 hydrogen. It is a planar triangle. Planar triangle or trigonal planar. Planar triangle or trigonal planar shape. Suppose one carbon atom can be considered. So it is like a trigonal planar. Okay, right. In this how many sigma and pi bonds are there? So remember, all single bonds are sigma bonds. All single bonds are sigma bonds. In between any two atoms, only one sigma bond will be present. Okay, now how many number of bonds? It may be 1, 2, 3, single bond, double bond, triple bond, but number of sigma bonds between any two atoms will be only one. So these are the single bond sigma, single bond sigma, single bond sigma, single bond sigma. So here double bond, one is sigma, so second one is the pi. So totally sigma bonds are 1, 2, 3, 4, 5. Ethene containing the 5 sigma, 1 pi, 5 sigma and 1 pi bonds. Okay, now the pi bond, how it formed? Due to unhybridized orbital, unhybridized p orbital, because only one s orbital, two p orbitals are involved, then one orbital p orbital is not involved, that not involved or unhybridized p orbital will be formed that pi bond. And previously we have seen that in the methane molecule, one s orbital, three p orbitals are involved, so result in the formation of 4 sp3 hybridized orbital. But in this case only one s orbital, two p orbitals are involved, one p orbital is unhybridized orbital, that unhybridized orbital will be forms the pi bond. Hybrid orbitals will be forms sigma bond. Okay, now condition apply. Hybridized orbital will be forms only sigma bonds, of course here also forming. Then what is the result of the pi bond? Unhybridized orbital, that is not involved in the hybridization. Okay, right. Next one is here in this character also can be see that yes, character is 33.33%, p character is 66.67% of yes. Next one, bond angles are 120 degrees, in between the any two 120 degrees, between these two 120 degrees, between these two 120 degrees. Okay, na? Shape planar triangle. What is the shape of the molecule? Planar triangle or trigonal planar. This is the sp2 hybridization. Next, sp hybridization can be seen. In the sp hybridization, only how many? One s orbital, one p orbital. So here s orbital and then p orbitals, 1, 2, 3. Here only intermixing of only one s, one p. Then what about the remaining two? Those are unhybridized. Each one will form that, which one? One pi bond. Same, take that one carbon. Here intermixing of one s orbital, one p orbital result in the formation of two sp hybrid orbitals. This is also called as linear hybridization. Linear hybridization. The bond angle is 180 degrees. Bond angle is 180 degrees. So you can see that here one s orbital, one p orbital result in the formation of, this is the one sp, this is another sp. So like this two sp hybrid orbitals are formed. So you can be take that first on carbon atom. Carbon is having the 4 electrons, no? So one sp can be it will be takes place. So you can be draw. So this is the sp of the one carbon. So then what about the 2? This is the unhybridized, this is also unhybridized. These are the sp hybridized orbital. This is the which one? Unhybridized. This also unhybridized. So between these two overlapping will be takes place. Each one is containing the one electron. So by this what happen? End on end overlapping, sigma bond, s orbital, second one, third one, fourth one. So here sigma bond will be forms. Then in between px, suppose say this is a px, this is a px, again this is the py, this is also this is the sp, this is the sp, and one more unhybridized orbital will be present. Okay, na? So yes, px, one sidewise overlapping, px sidewise overlapping, and then here one more unhybridized orbital will be. So in between these two also one overlapping will be takes place by result of, suppose carbon, okay na, another carbon. So here forming the which one? Carbon single bond, and here two pi bonds. One is sigma, two pi bonds. Okay, now how the two pi bonds? One is due to suppose px is involved, suppose px py. Okay, now px px will be forming that one bond, py py will forming that one bond. Then pz is pz and s orbital is involved, that is called sp hybridization. Next one, here one electron will be, here also one electron, no? So that will be forms with hydrogen, s orbital, s orbital. So this bond is here, which one? This bond is sigma bond is sigma sp s. This bond sigma bond is sigma sp sp, and this sigma bond is sigma sp s. Then what about the pi bond? Px px, pi py, px pyx, and this pi py py. Okay, now this is one pi bond, this is another pi bond. Okay, this is the sp hybridization. Okay, now intermixing of atomic orbitals here, which one s and one p. So that's what sp hybridization. Sp, due to sp hybridization, one sigma bond can be formed. Okay, and unhybridized orbitals will be formed at pi bonds. Okay, okay sir, ఇప్పటిదాకా బాగానే చెప్పారు హైబ్రిడైజేషన్ గురించి. దెన్ మనం ఎలా కనుక్కోవడం, how can we know the which hybridization is present in a given molecule? It's a very simple. Okay, na, it has a formula, so based on that we can be easily calculate. So first one is here, whatever given molecule, first of all you should know the structure. Okay, na, suppose ethane molecule, ethene and ethine. Ane is nothing but which containing the carbon carbon single bond. Ene is nothing but carbon carbon double bond. Ine is nothing but carbon carbon triple bond. Okay, na, right. So here yesterday discussed that in the structure, while writing the structure, so must be satisfy the four bonds. So the four bonds will be, so in that one bond with one carbon, remaining three bonds with three hydrogen atoms. Okay, now so carbon carbon hybridization is only, that means here only one sigma bond. Here double bond. Double bond means two more bonds only, a chance. Like this we can be draw the structure of ethene and ethine, carbon carbon triple bond. Carbon carbon triple bond means it can able to form only one bond. Okay, na, right. Here hybridization can be based on the formula, can be follow that. So it can give the one number, the number is equals to which one? Number of sigma bonds plus any lone pairs, but here lone pairs we won't be see. So number of sigma bond plus lone pairs, so that can give the which one number. If the number is 2, the hybridization is sp. If the number is 3, that is called sp2. If the number is 4, that is called sp3. Okay, now very simple. Find the number of sigma bonds. Lone pairs is not at all will be in this here. So only sigma bonds you have to calculate. If the number of sigma bonds are 2, so that is indicating that sp. If the number of sigma bonds around the atom, that is a sp2, and if the number is 4, that is called sp3. So suppose here two atoms are there, for each atom will be calculated that hybridization. Suppose you can take the first carbon, around this 1 2 3 4 bonds are there, so 4 sigma bonds. 4 sigma bonds is nothing but the number is 4, that is equals to sp3. The hybridization is sp3. This carbon atom 1 2 3 4, sir, this bond mean 2 times calculated. Of course the bond is sharing in between the two carbon atoms. Okay, na, right. That's what here, this is also sp3, this is also sp3. Okay, here 1 2 3 4 bonds, but in that 4 bonds single bonds are sigma. Okay, then double bond is 1 sigma 1 pi. So that's what sigma bonds are how many? 3 sigma. 3 sigma is nothing but sp2. 3 sigma is nothing but sp2. Take this compound 1 2 3, this is also sp2. Then coming to this, triple bond is present. Triple bond means 2 or pi bonds, only one is sigma. One sigma, here one sigma. Only 2 sigma. 2 sigma is nothing but sp hybridization. Sp hybridization. Okay. So here number of sigma bonds can be used at hybridization type. So they can give on compound like this. Last that, find out the type of the hybridization in the given compound. Hybridization in the given compound. So first carbon, that means here nothing will be means that is attached to hydrogen. Okay na, inka dani particularly manami tension padaల్సిన అవసరం లేదు దానికి. So hydrocarbon, carbon is attached with hydrogen. So how can you write, sir, those many hydrogens? So you have to check the here valency. నేను అన్ని చోట్ల రాశాను, బట్ ఇక్కడ అన్ని చోట్ల అది కరెక్ట్ కాదు. ఎందుకు కరెక్ట్ కాదు అంటే, ఓకే, ఫస్ట్ వన్ ఈజ్ 4 కార్బన్ ఐటమ్స్, 1 2 3 4. ఓకే, 1 2 3 4 5 ఉంది ఇక్కడ. సో హియర్ ఇన్ ఆల్ ద కేస్ ఈచ్ కార్బన్ ఐటమ్ విల్ నాట్ హ్యావ్ దట్ 2 హైడ్రోజన్ ఐటమ్స్. కంపల్సరీ కండిషన్ ఏం లేదు. ఇక్కడ వ్యాలెన్సీ మనం కన్సిడర్ చేసుకోవాలి. 1 2 3 4 మనం డబుల్ బాండ్ని చేంజ్ చేయడానికి ఛాన్స్ లేదు. సో వీ హ్యావ్ టు లెస్ ద నంబర్ ఆఫ్ 1 హైడ్రోజన్. ఓకేనా, హియర్ ఆల్సో 1 2 3 4 5. So here also can be remove this hydrogen. Okay na, అన్ని చోట్ల మనం CH2 రాయలేం. So based on that now double bond and single bonds or triple bond valence, double bond triple bond we cannot be change. Okay, ఇక్కడ triple bond ఉంది కదా, double bond ఒక 2 bonds చేసేద్దాం. So you don't do like that. Okay na, the double triple bond you must be consider. Here one, so here no need to write the valency of the hydrogen. Okay, ఇక్కడ ఏం లేదు, 1 2 3 4 5 6 అవుతుంది. 6 అయినప్పుడు మనకు రాదు ఇక్కడ. సో see now it can be check it. So this one 1 2 3 4 again 4 valency. This one 1 2 3 4, this also 1 4 1 2 3 4 correct, 1 1 2 3 4 correct, 1 2 3 4 correct, 1 2 3 4 correct. Now hybridization, you have to use this formula. Number of sigma bonds only can be calculated. 1 2 3 4. So first carbon is sp3. First carbon is sp3. Second carbon 1 2 3 4, this is also sp3. Okay, 1 2 3 4, 4 bonds are there, but in here one double bond is nothing but 1 sigma 1 pi. What you have to consider? Only sigma bonds. That's what 1 2 3 sigma bonds. 3 sigma bonds is nothing but sp2. Total number is 3 is nothing but sp2. And this one 1 2 3 4, this also same sp2 because 1 pi bond, only 3 sigma bonds. Here 1 2, here triple bond means only 1 sigma remaining, 2 or pi. Just now I said that between any 2 atoms only 1 sigma bonds, only 1 sigma bond present. Okay, now 1 2, that means this is a sp. 1 2, this is also sp. See here in the same compound sp hybridization, sp2 hybridization, sp3 hybridization is present. Okay na, మనకు ఒక కాంపౌండ్లో ఒకటే హైబ్రిడేషన్ ఉండాలి అనే రూల్ ఏం లేదు. సో ఈచ్ ఆటమ్ కెన్ హ్యావ్ ద డిఫరెంట్ హైబ్రిడేషన్. సార్ కార్బన్ కనుక్కున్నారు, మళ్ళీ హైడ్రోజన్ ఈజ్ నాట్ హైబ్రిడైజ్డ్ ఆర్బిటాల్, ఇట్ ఈస్ హ్యావింగ్ ఓన్లీ 1 ఎలక్ట్రాన్. ఓకేనా, సెంట్రల్ ఆటమ్కి మనం హైబ్రిడేషన్ కనుక్కుంటాం. ఓకేనా, సో దిస్ ఈస్ ద రిగార్డింగ్ ద హైబ్రిడేషన్ కాన్సెప్ట్ sp3 sp. ఓకే, నెక్స్ట్ ఇక్కడ ఒకటి ఈ మీథేన్ మాలిక్యూల్ చూద్దాం ఒకసారి. మీథేన్ మాలిక్యూల్, మీథ్ ఈజ్ నథింగ్ బట్ ఓన్లీ 1 carbon atom, 4 bonds are there. So each bond is to hydrogen. So here 4 bonds, 4 sigma is nothing but sp3. Sir, methane you have written, sir, then whatever is there methane. So to exist the double bond must be 2 carbon atoms are required. Okay na, in between the 2 carbon atom double bond it is said to be in between the 2 carbon atom that is said to be ine. But here single bond exist అవ్వాలంటే 2 carbon atoms అవసరం లేదు. Okay na, that means smallest hydrocarbon is methane. So hybridization is sp3. Bond angle is 109 degrees 28 minutes. Okay sir, what about diamond and graphite? Diamond and graphite హైబ్రిడేషన్ అనుకుంటాం, ఇందులో మనకు sp3 వస్తుంది. ఎందుకంటే ఈచ్ కార్బన్ ఈజ్ connected with 4 other carbon atoms. Again this carbon is connected with 4 other carbon atoms. Okay na, this again connected with 4 other carbon atoms. Okay na, itla vastundi. So one carbon is connected with 4 other carbon atoms, not with hydrogen. That's what diamond will not comes under the organic compound. గ్రాఫైట్ ఆఫ్ కోర్స్ హైబ్రిడేషన్ మనం తీసుకోవచ్చు. ఇక్కడ sp3 ఉంటుంది. గ్రాఫైట్ వచ్చేసి ఎలా ఉంటుంది మనకు? సో ఇట్ ఈస్ ద hexagonal structure. Each one is representing that one carbon. Okay, that means each carbon is connected with 3 other carbon atoms. That's what here hybridization is sp2. డైమండ్ లో sp3 ఉంటుంది, గ్రాఫైట్ sp2 ఉంటుంది. బట్ రెండు కూడా మనకు ఆర్గానిక్ కాంపౌండ్స్ కింద రావు. సో అని చెప్పుకున్నాం ఎస్టర్డే. విచ్ వన్? కార్బన్ మోనాక్సైడ్, కార్బన్ డైఆక్సైడ్, నెక్స్ట్ వన్ కార్బోనేట్స్, నెక్స్ట్ వన్ ఈస్ బైకార్బోనేట్స్. ఓకేనా, నెక్స్ట్ సయనేట్, diamond, graphite. These are not comes under organic compounds, because here only pure carbon, one carbon is connected with another carbon atom. There is no other hydrogen atom or any other atom. So this is the regarding the concept of hybridization. Okay na, hope you understood this. Okay, right, thank you. And in the coming video I will be explaining about the classification of the organic compounds, and then I will move to nomenclature. Thank you. Please subscribe to my channel and support me. Thank you.